right, 51 says, I have 24 workers on the first shift. I have 17 workers on the second shift. Start out like this, 24 first shift, 17 second shift. How many workers do I employ? 41 altogether. Okay. 8 workers are chosen at random to be interviewed about the work environment. Find the probability. Probability means I have 2 lines here, a top and a bottom, a specific and a generic, if you will. Think of it that way. This is specific, this is generic. Generic means what? Any 8 people. How many groups of 8 can I make? From how many people? 41. How many groups, non-workers, just groups of 8, can I choose from 41 people? That's my generic. My specific part, the part I need, is I want 6 of them to be first shift workers. So write it like this. 6 first. But I have to have 8 of them. So where are my other 2 going to come from? If 6 came from my first shift, they got to come from my second shift.
Aren't you only looking at the first shift, or it doesn't even matter?
Say that again?
Aren't you only looking at it for the first shift?
Well, you want the probability that your 8 people that you chose contain 6 first shift workers. So out of those 8 people, here's my 8 people. First shift, first shift. I need to have 6 of these, right? But I have 2 other people that I'm choosing 8 with. So where are they going to come from? My second shift. I still need to get 8. And they only told me 2 things. You got a first shift, you got a second shift. So I took my generic group, any 8 from the 41. Once you get to this part, how many first shifts do you have to choose from? 24. How many do you want? 6. How many second shifts do you have to choose from? 17. How many of those do you want? Counting principle says to multiply those 2. I would just throw that whole thing in my calculator. Yes?
So the second number of both the numerators have to equal the second number of the denominator?
Yes. Aren't I still choosing 8? I'm choosing 8. They have to be the same.
And that goes for the first 2 numbers?
The first 2 numbers, these have to add up to my total.
Yeah, for that.
Yep. Good way to look at it. Consider this a specific case over my generic case. Generic means any. I don't care where you get these 8 people from my first or second. How many groups of 8 people can I actually make? I can make a heck of a lot of groups of 8 people out of 41, can I? But specifically, only want the groups that have 6 people that's from the first shift in them. 2 of those people got to be second shift workers. Find the probability of choosing 4 second shift workers. How many are they still choosing? How many are they picking from? 8. They still have 8. So generic, that bottom number is not going to change. So now you want 4 second shift, but you still need to choose 8. So where's the other 4 coming from? First shift. Start like this. This is such a good way to start. Then say, okay, from the second shift, how many do I have to choose from? 17. And I want 4. Counting principle says multiply. How many do I have in my first shift? And how many do I want? 4. Over my any groups of 8, my generic number. Good? That's what we're looking at. What do they call these? First shift, second shift, defectives, non-defectives, group A, group B. It's still the same principle. Still the same principle. Where the defectives come in, it's weird because whenever they use a not or a non, it throws everybody off. When they say non-defective, what does a non-defective mean? It means it's good, right? So when they throw that in there, it looks weird, but the process is exactly the same. So let's tackle the next one. Oh, that was that one. Okay, so now comes your big one. I need a shipment of 10 microwave ovens. And in my shipment of 10 microwave ovens, there are 2 defective units in my shipment of 10. I don't know that, of course, but this is what they're sending me, 2 shipments. 2 defectives in my shipment. So how many are good? 8. Even though we say these are good, there's nothing wrong with them, we can still call them non-defective. Always start with this, because if you don't, you're going to miss how many in total you have. You're going to miss how many of the other group you have, because you're just going to focus on the 2 and the 10. So now it says, a restaurant buys 3 of these units. They're choosing 3. What is the probability? Part over whole, specific over generic. Let's work the bottom part of this. I'm choosing 3. From how many microwaves? 10. I'm choosing 3. I want at least 2 non-defectives. Hold off on the word at least yet. Okay, let's cover that word for a second. Let's work on the 2 non-defectives. So if I get on my top 2 non-defectives, I need 3. Where does the other one come from? My defective. My non-defectives are my good. Same process, isn't it? Isn't it the same exact principle? Yes?
Yes.
Everybody's going like, oh my gosh. Yes, same principle as this. So how many non-defectives do you have to choose from? Non-defectives. 8. Non-defectives are our good. Even though they have the word defective, it's non-defective. Counting principle says multiply. How many defectives do you have to choose from? 2, and I want 1 of those. Okay. Now, that's the first part of this. It said at least 2 non-defective. Like I don't want to get all defectives, obviously, and I don't want too many defectives. I want 2 non-defectives out of 3. So I'll take 2 non-defectives and a defective. Or, because I have an at least, what else will I take? 3 non-defectives. Or 3 non-defectives. I got an at least case in here. 2 non-defective or more non-defectives. But how many am I choosing? 3. So now I want 3 non-defectives over my generic group. How many non-defectives do I have to choose from? 8. And how many do I want? 3. Now, in probability, an OR statement says do what? Add. So there's your statement. You're going to take this guy plus this guy. Make sense? It only makes sense if you lay out all the parts to it. If you try to keep looking back and forth, you'll never get it. Because an OR says add together. I give you more choices in an OR. So if I say, it should be just like the other one. Now, they gave you this amount. Set this up. 3 defects. Got to add up to 250. 247, non-defect. Call it good. That's fine. This one asked how many ways. This one asked probability. So how many different orders of, how many am I selecting at the same time? I didn't read the rest of it. 2, 3. We're selecting 3. Okay, so we're picking up 3 units. I need to pick up 3 units. How many ways can I go to your non-defective units? How many non-defective units do you have? How many groups of 3 can I make in those? Okay, that's how many ways. Probability says over the generic. What's going to be my generic? 250C3. I don't care if they're good or bad. I want all together. So now I'm just going to take this guy and put it right over this. Do you see the difference? I also did have, so I said do 6A and 7A at the same time. It would no sense going back to it and saying, what did I do in this 6A? If you're getting 3 non-defective units, there's only a certain amount of ways you can make groups of 3. Okay? I want all defective units. How many defective units are there? So how many groups of 3 can I make out of 3? 1. So therefore, what's the probability that I got all defective units? Here's my generic, 250 out of 3. This is your 3C3, or 1 out of that answer. How many ways? There's only 3 units. How many groups of 3 can I choose? I've got to just choose those 3 units. 3C3, sorry. I'm saying there's 1 and I wrote the 3 instead of the 1. You're only going to get this one way. One.
I put like 247C0. Can I do that?
No, 247C0.
Well, times it by the 3C3. I guess still got the same answer.
Oh, you're just adding the other part to it?
Yeah,
Oh, you're
so
putting it on the numerator?
Yeah,
Yeah, if you wanted to do that you had none from there.
yeah, basically.
Yeah. I thought you meant you put your numerator as
no,
that.
no.
Yeah, no. Yeah. You can, that's the 0 there, but. Okay, now, here's a little tricky part. How many ways first can I choose at least 1 good unit? So I want 1 good unit, or 2 good units, or 3 good units. And I would have to add these. What is the only condition that I don't want? 3 defectives. I'm 1 minus 3 defectives. So how many ways can I do this? Where's my 3 defectives? Only one way. Only one way that can I do this. So take this guy and subtract it take your basic one and subtract the 1. Use your complement case. It's much, much easier than adding the 3 of these. So you're going to say your 1 minus your 3 defectives. This is 1 over whatever this number happens to be. I didn't work them out. And it would be really, really small, really, really a large number, right? The probability that you get at least 1. This is going to be a very, very, very small number. So shouldn't my probability be really large that I'll get at least 3 good units? 250 is a lot larger than 10. 10 microwaves versus 350 units, the probability will change.
So use the complement case for the probability?
Yeah, use your complement case.
Not,
Oh yeah, use your ways. Just take out the 1 out of how many ways you can do it. Just take your ways and take out the 1. But your probability's got to be really, really strong. So out of 250, you only have 3 defectives. So that's the only case I don't want. I didn't work this out, but wouldn't this be very, very small? As opposed to when I had 10 microwaves with 2 defectives? Yeah, it's got a lot of 0. It's probably scientific notation. Don't forget to move the decimals over. But if I'm talking 10 microwaves and 2, that number's not as small because my numbers are less. But these numbers are huge. Okay, I threw another part in here. I want 2 defective units. Not that I want them, but what is the probability that I will choose 2 defective units? How many ways first can I choose 2 defective units? Yeah, because that's going to be your top number. That's going to be your top number anyway. So how many ways can I choose 2 defective units? This is what I want. 2 defects. I'm choosing how many things? 3. So if I choose 2 defects and I need them to add up to 3, I'm choosing 1 non-defective unit. Let's start like this. How many defects do I have? 3. How many do I want to choose? 2. counting principal, times how many non-defectives do I have? How many do I want? 1. There's your how many ways. How do I get my probability then?
Put it over.
Put it over the general one, the generic one. Put it over this guy. Any groups of 3. Any groups of 3. And that should be a good number too.
Can you show, like, for 3C, common case, can you show not, like, the actual math, not just the
Are
ways?
you in this one?
Yeah, for the top one.
Can you do all 3 of these?
For the ways.
Yeah, you can.
Can you show it?
So if you did one good, let's just go to the probabilities. If you did one good, you'd have to have one good and how many defects? 2. So one good, you have one of these times 2 of these plus 2 good. How many of your goods? I want 2 of these times 1 defect plus, and then just put these all over the bottom number. These are your how many ways.
Right.
3 good, and that's how many ways you would do that. I mean, you can do that, but the only one that you don't have is the non-defective ways. That'd probably be easier. Come to your defective ways and just subtract that. Yes. Yep, you just take this. This was how many ways, and probability, just put it over your denominator. Okay. What if I said I want, okay, do this. What if I said I want the probability of 1 defective unit? Set that up for me. Find me just the probability of getting 1 defective unit out of the 3. This is always a difficult topic. It is.